most of us who have studied evolutionary theory and evolutionary biology, especially with regard to the creation versus evolution controversy, have at least once come across the statement that according to evolutionary theory, or it is a prediction of evolutionary theory, that creatures should be simpler and more similar in the past as we trace their lineages backward through time. And as more distantly related lineages converge, we should see them becoming the same and simpler. The idea here being that evolution is some sort of force that impels living things to magically diversify and become more complicated over time, and that if evolution is true, we should naturally expect, as we go in the past, to see things happening the other way. We should see creatures undiversifying, seeing distant lineages eventually converge into the same lineage, and that if creatures become more complex over time as we trace their lineages backward through time, we should see them becoming simpler in the past, more complex in the future. That is the direction of evolution. Recently, I had the pleasure of taking a class at the Evergreen State College in spring quarter of 2018 entitled Truth and Reason, taught by purported biologist Karen Hogan and physicist Alan Olson. In this class, they gave a even more and more troublingly specific version of this claim, which was that if naturalistic evolution were true, as opposed to some sort of driven evolution, like, let's say, theistic evolution, or maybe some kind of alien-tampered evolution. But yeah, if naturalistic evolution were true, as opposed to some form of theistic or at least driven evolution, then we would expect creatures to gradually become more complex over time. A smooth sort of upward slope in complexity, with the obvious exception of mass extinctions and living fossils, creatures who have managed to evade the forces of natural selection for millions of years. But yeah, said that if naturalistic evolution were true, we would expect a gradual increase in complexity over time, without any sudden bursts or dips or spikes or anything like that that we might expect in a theistic evolution model or a driven evolution model, and that's kind of even more disturbing. Yeah, said that if evolution were true, if naturalistic evolution were true, we would expect a gradual increase in complexity over time, not a stilted or haphazard or uneven increase in complexity over time, which my instructors, both Karen and Alan, seem to think the latter of these, a stilted or uneven increase in complexity over time, would imply a creator or evolution being tampered with once in a while. Of course, most people nowadays would never admit to evolution having an inherent direction, and if you were to ask them point blank, is there a direction to evolution, most of them would give an emphatic, enthusiastic no as a reply. But if you're not asking them that point blank, usually they'll, in other places, if they're not thinking about that, lapse into this sort of idea of evolution being a magical force that makes things become more complicated over time, like the Star Trek version of evolution. And of course, after any version of this claim, whether it be the insanely specific version that I heard at the Evergreen State College, or the more general version that we should just expect creatures to be simpler and more similar in the past, the claim is usually followed up with the claim that that's exactly what we see in the fossil record, which honestly makes a really convenient little soundbite for us to use against the creationists. You know, if evolution were true, we would expect creatures to be simpler and more similar in the past. And when we look at the fossil record, that's exactly what we see. Um, or if evolution were true, we would expect creatures to become more complicated or more complex over time as they evolve, and in the past we would expect them to be simpler. Simpler creatures first, more complex ones later. That's what evolution predicts, and when we look in the fossil record, that is exactly what we see. But if you ask them point blank, evolution has no inherent direction. Of course, most people, even today, even lay people, know that evolution is not some magical force that makes things more complex over time. I mean, consider, what was it, the 2001 movie Evolution, starring David Duchovny and Julianne Moore. Um, the aliens who contaminate the Earth, they start out as microbes, and they reproduce at an incredibly high rate when exposed to heat energy, like, for example, the heat energy from the impact of the meteor. And the government that has not put this together yet, hasn't realized that the creatures evolve more quickly in response to heat energy, it decides it's going to end the alien threat by napalming the meteorite cavern where the creatures were all spreading from, and predictably things go terribly, terribly wrong. The organisms start reproducing and therefore evolving out of control, and in a couple of minutes you have a giant amoeba-like organism lurching across the landscape. One of the main characters looks at this giant, colossal, gargantuan amoeba creature lurching across the landscape, looks at it and says, "That's evolution?" To which Julianne Moore's character replies, "The simplest organisms are often the most fit." Bravo, the movie Evolution. Bravo. The simplest organisms are often the most fit. It's not every day you see a major motion picture handling evolution that well, or actually interjecting something into a major Hollywood production about evolution that is not a misconception that someone of the general public would have. Seeing someone actually comment in a major Hollywood movie that the simplest organisms are often the most fit was so refreshing. And it was around this time in the late 1990s and the early 2000s that the Wozian revolution of the late 1900s was finally starting to filter down into the popular culture and into popular science sources. You know, we were starting to see more of this new view of evolution that had emerged in the late 20th century. More on that later. So where did this idea come from that creatures should be simpler and more similar in the past, that they should be more complex in the future, and even more strangely, where would this idea come from that a gradual increase in complexity would be more consistent with naturalistic evolution than a stilted or uneven increase in biological complexity over time? And why would the stilted or uneven increase in biological complexity over time somehow be indicative of guided or driven evolution, such as theistic evolution or alien-guided evolution? Where are these ideas coming from? Well, firstly, it's important to understand that zillions of years ago, in the moldy old 19th century, people looked at the fossil record and they saw creatures much more like modern creatures, and a higher proportion of mammals and birds as opposed to reptiles, fish, whatever. Um, in the more recent rock strata. And as we went backward through time, we would see fewer warm-blooded creatures, fewer mammals, more reptiles. Reptiles were generally regarded as less fit. Mammals were seen as inherently superior to mammals, or inherently superior to reptiles. You know, it was kind of this ladder of life philosophy where where mammals and birds were kind of seen as superior to reptiles, which were in turn superior to amphibians, which were in turn superior to fish, which were in turn superior to other chordates. Yeah, this whole idea that you could rank organisms on some kind of evolutionary ladder. Scientists didn't really believe that anymore. Even in the 1800s, they saw the evolutionary tree of life as, just that, a branching tree with lineages diverging and going in different directions. So, of course, even back in the 1800s, scientists didn't really literally believe in a ladder of life anymore. Not a ladder of life per se, or a great chain of being, but those philosophies had so influenced evolutionary thinking that even as they switched over from a chain of being or a ladder of life to a branching tree, the idea that the topmost branches, the superior branches, were actually more complex and superior organisms, and that the inferior branches were actually more primitive organisms. That kind of thinking had so firmly rooted itself into evolutionary thinking that even for most of the 20th century, people were loath to let it go. They didn't want to give up this idea of humans being the most complex creatures who had ever lived, and us being at the pinnacle of some kind of evolutionary process driving toward ever more complex, ever more sophisticated organisms, and human beings being a relatively recent organism that's only been around for, say, 100,000 or 200,000 years. That's really flattering. If you're going to make the newer species the more complex ones, and the older species the more primitive ones, then I guess that makes us one of the most complex of the most complex, right? I mean, it's a really flattering story for humans, and that's it wouldn't have been recognized in the olden days, in the 1800s or in the 20th century. But nowadays, the fact that story is so conveniently flattering toward humans would raise serious red flags. But let's examine our original claim that according to evolutionary theory, or evolutionary theory predicts that creatures will be simpler and more similar in the past. Is that really true? According to the law of phylogeny, obviously creatures have to become more similar in the past. You shouldn't necessarily expect them to become gradually more similar as we go backward through time. Some people say creatures become simpler and more similar in the past as we go back in time, and that almost but not quite implies that no matter where you look in the fossil record for any creature, if you go back a little bit further than that, it will look more similar to its ancestor, and that's not always the case. Creatures don't have to diverge at consistent rates, although that's more of a quibble than anything else. Would we expect creatures to be simpler in the past and more complex in the future? Now that's a completely different story. Given the theory of evolution just by itself, now remember, evolution is defined as a change in allele frequencies in a population over time. Alleles being different versions of the same gene. So if you have a population that goes from let's say 10% blue-eyed people and 90% brown-eyed people, and over the course of a couple of generations it becomes like 90% blue-eyed people and 10% brown-eyed people, that would be a change in allele frequencies over time. Technically, that would be evolution. It obviously wouldn't it wouldn't be the sort of example of evolution that would satisfy any creationist, obviously. It's definitely in the realm of what those guys would call microevolution. Well, actually, it's what we would call microevolution too. It's one of those cases where we would both agree. Uh, but yeah, that's all evolution is a change in allele frequencies and populations over time. And evolutionary theory really doesn't predict anything more than that. It just predicts that that there will be change over time. I mean that's really all there is to it. There's no directionality to it. There's no implications that the change will be in this direction or that direction toward increasing complexity or decreasing complexity, whatever. Evolutionary theory says nothing about that. It is literally just allele frequencies changing in a population over time. So if creatures become morphologically more complex over time due to a change in allele frequencies or multiple accumulated changes in allele frequencies, would that be evolution? Yeah, definitely. But so would a decrease in complexity over time. You know, so's any kind of evolutionary change. All evolutionary change is evolution. Big surprise. Um, So yeah, all this stuff about increasing complexity, it's not really part of the definition of evolution. You can't really consider it a prediction of evolution or one of the things you would expect to be true if evolution was true. In fact, according to the rare earth hypothesis and numerous different hypotheses within the realm of evolutionary biology, but I'll stick with the rare earth hypothesis because it's probably the most widely known among lay people. According to the rare earth hypothesis, if the solar system weren't arranged in such a way that Earth were an ideal habitat for creatures to survive in. For example, if we didn't have a large moon to stabilize our orbit, if we didn't have Jupiter around to deflect asteroids that were coming toward us, if we didn't have an ideal situation going on here in the solar system, then probably complex multicellular life never would have evolved. But these theories like the rare earth hypothesis and other theories that conjecture increasing complexity only under um, low selective pressure environments, possibly as some sort of buildup of entropy. Um, they they shine a spotlight on how much of a butterfly effect we're really dealing with. I mean, Stephen Jay Gould used to say that if we were to rewind the clock on evolution, we wouldn't necessarily expect things to play out the same way again. We wouldn't even necessarily expect to get complex multicellular life a second time. So it's definitely true that according to phylogeny, which is an important part of evolutionary study, because it traces family lines over time and how creatures have actually evolved, um, according to phylogeny, creatures should become more similar as we trace their lineages backward through time. Not necessarily at a gradual, consistent rate. Um, for example, we might not see a particular pair of lineages becoming very similar to one another as we trace them backwards until right before we reach their common ancestor, what Richard Dawkins calls their concestor. Um, So we would expect, given phylogeny, for creatures to become more similar in the past eventually. We would absolutely not expect, given evolution were true, um, for creatures to become more complex over time. I mean, that's a possible outcome, obviously, but there's no reason to expect that particular outcome. Um, And so to try and make that a prediction of evolutionary theory, to try and say, you know, according to evolutionary theory, creatures should become simpler and more similar in the past. More similar, yes. Simpler, no. That's just not a part of evolutionary theory. I mean, I'm sorry if you're attached to the idea, uh, and it could turn out to be true. I haven't gotten to that part yet. Um, that things have become more complex over time, or rather that that individual living things have become morphologically more complex at the organismal level, which is pretty much what we've been talking about all along. For any given species or lineage, will the average member of that species or lineage become more complex over time? That is more morphologically complex, more anatomically complex. And now that's really the question for the second part of either of those claims. The first part being that evolution predicts that creatures would become more complex over time, or that they would appear more simple as we trace their lineages backward in time through the fossil record. Um, So we know that's not actually a prediction of evolutionary theory, but what about the second part of the claim that that is what we see in real life? Do we? We'll explore that part in part two. So stay tuned.